chemists, and welcome back to Chem Class with Casey. Today we are going to be learning about solubility product constants. To start off, let's review what we know about the K constant. The value of a chemical reactions quotient at equilibrium is the definition of the K constant. In other words, this can be defined as products over reactants. However, this only applies for aqueous and gaseous solutions. No liquids or solids here. Something doesn't seem right with this equation. Can you point out the mistake?
I think you're missing a 2 up there.
That's right. We're missing a 2 right here because of the cross charges. Now, we could put a 1 right here because of the 1 negative charge on the OH, but it's not really necessary. Now, we have to go over 2 things to make sure that we can solve for the K constant for this equation. Are the ion concentrations of the products equal? No, so it's going to make it harder for us, but it's still possible. And is this solution saturated? Yes, which means we're all good with this one. Now, as we said before, the K constant is products over reactants. However, solids are not included in this equation. So our final equation reads magnesium with a 2 plus charge times hydroxide with a 1 negative charge. But don't forget the 2 constant in front of the hydroxide in the original reaction. We're going to put that in the exponents place after the hydroxide in our final KSP equation. So we get the solubility product constant is magnesium with a 2 plus charge times hydroxide with a negative charge squared. Now it's time for the fun math stuff that everybody's been waiting for. We are given the problem, if KSP equals 1.6 times 10 to the negative 11, calculate the ion concentrations for both magnesium and hydroxide. Well, here's our equation that we just came up with for the solubility product constant. Now, we see that the charges are different, which means that our X values are going to be different. So for magnesium, we take hydroxide's charge of negative 1 and put it in front of the X, which makes it 1x. And then the 2 plus charge in front of magnesium goes to hydroxide, which makes it 2x. However, we can't forget that hydroxide was squared in our equation, so we put it in front of the 2x. So we get 2x squared equals hydroxide and x equals magnesium. Now we can put this back into our solubility product constant equation as x times 2x squared. Now we plug in what we know, 1.6 times 10 to the negative 11, and solve for what we don't know, x. So here we have this equation. We can simplify x times 2x squared to 4x cubed, cancel everything out, and then we get 1.6 times 10 to the negative 4 equals x. All done, right? Wrong. The problem was asking for the concentrations of both magnesium and hydroxide. So we plug them back in to each of our values. So we put 1.6 times 10 to the negative 4 equals x, and 1.6 times 10 to the negative 4 equals 2x squared. Then we solve, and we get magnesium equals 1.6 times 10 to the negative 4, and hydroxide equals 3.2 times 10 to the negative 14. But don't forget your moles, because molarity is moles per liters of solution. Good work today, chemists. I'm super proud of you guys. Make sure you tune in to the next episode of Chem Class with Casey for all your chemistry needs.